Hello, everyone, and welcome to the GeekNerdR podcast. I am your host, Kaivalya Apte, and today we are going to talk about stream processing. I am joined by Apoorva Mehta from Responsive and Yingjun from Rising Wave, and we are going to learn about stream processing trends, some challenges, some discussions around different paradigms, and some questions that our followers have for our experts. So, with this, welcome Apurva and Yingjun. Let's start with a little bit of introduction about yourself, about your background. Did you end up creating Responsive, and for Yingjun Rising Wave? And yeah, let's get started. Let's maybe start with Apurva.
Thanks, Kaivalya. It's great to be here. Awesome job on the podcast. It's getting pretty famous, so it's nice to be here. Yeah, so I'm Apurva. I'm co-founder and CEO of Responsive. And Responsive, we're building what we call a solution for Kafka Streams. Kafka Streams is a stream processing library, and our solution basically redefines the scale, reliability, and operability of Kafka Streams. So that's what I do now. We're like a year and a half old. And before this, I was at Confluent. I was pretty early there, an early engineer where I added transactions to Kafka. I helped add transactions to Kafka, and then I ran the KSQL Kafka Streams teams. So I've been, coming up to 10 years deep in the Kafka world. So that's my background.
Awesome. Yeah, Yingjun.
Uh, okay, yeah, I can do a pretty quick intro. I'm Yingjun Wu, and I'm the founder of Rising Wave Labs. So Rising Wave is a stream processing system, specifically a streaming database. Basically, yeah, what a streaming database, well, we can definitely discuss later. But in one sentence, is okay, give the people the experience or database experience for stream processing and analytics. So I started a company 4 years ago, and before that, I was at AWS Redshift. But essentially, I started working on stream processing probably 10 or 12 years ago. Before when I was a PhD, my thesis was about the stream processing and database systems. And then I moved to IBM Research when doing things like Event Store, basically DB2 Event Store, which is also like a streaming system. And then Redshift, and then starting my own company. And definitely, I think what stream processing is, well, it's pretty. A lot of people are talking about stream processing, but I have to say that well, there are definitely tons of things, well, more things to be done. And I'm super excited to talk more about stream processing today.
Awesome. Yeah, you folks have much more experience in this world of stream processing, and you have seen this industry and this pattern evolve. And I want to start there. So, just to give a little bit of background about my experience in stream processing. So, I've used Kafka Streams in production, and I've used Apache Flink. I've played a little bit with Rising Wave. I've played a little bit with KSQLDB, but nothing at production scale. And if, at least in my experience, there is a lot of challenges when it comes to doing stream processing in the right way. And there's different motivation for different people. Some people want to save costs, some people want to make real-time decisions. And still there's a lot of question, is stream processing for us? Or is it something that batch processing could solve for us? And now it's more like they have unified processing for batch and stream, and they have a mixed architecture. So I want to start understanding from your perspective. Let's go through a journey of stream processing. Like, how did it all start, and how is it going right now? And what is going to change in the upcoming future?
Probably, yeah, I can probably give some background. As I just mentioned, I started working on stream processing around probably 12 or even 12 years ago, and actually probably 13 years ago. And at that time, I was doing research. But essentially, stream processing came from the academia. And the first paper, I still remember that well, it was essentially published by professors from MIT, Brown, and Stanford. And so basically what they did is that, okay, they have at that time, around the 2000 and 2002, basically at that time, we only have database systems. But the thing here that we are thinking about, okay, whether we can use database system to do monitoring, right? Whether we can do something like a stock monitoring or probably telecommunication monitoring. But stream process database, conventional database could not fit into that kind of use cases. So that's why people start working on, okay, think about, okay, whether we can process data once data comes in. And then people start, okay, let's do something called stream processing in a database system. and it was essentially called a stream database. But then people know that people started working on MapReduce, started working on Hadoop, and then people think about whether we can do stream processing in the big data world. And then we have, they say, I think at that time there was some systems called Hadoop something. I forgot the name, probably Hadoop or some other systems where that allowed people to do stream processing in Hadoop. And then some other system was invented like Samza, like I still remember there's a system called S4, and then Flink, and then probably Spark Streaming and some others, right? But now, these days, where everyone is talking about, cloud, right? Cloud native, everything should be built from cloud. And that's why we find that, there's essentially a chance we can build something from scratch again, because the conventional big data systems could not fit into a cloud. They are not designed for the cloud. And that's why we actually have the chance to build a new type of systems, right? Basically a cloud native system, so as to allow us people to process data streams in a cloud native way, which could be easier to use and which could be also way more cost efficient, because the entire system was built on top of the cloud. And that's what I can see, how stream processing got evolved from 20 years ago. Yeah, from the stream database, the stream processing component in a database system, and then to the big data system, right? And then evolve into a cloud native system. That's how I can see.
Interesting.
Cool. Yeah, I have a little different perspective from Yingjun. I think it's less academic. So I didn't mention in my intro, right? Like it's less rooted in academia because that's not the world I'm from. That's what I meant. Sorry, Yingjun. I didn't mention in my intro, but I was at LinkedIn before Confluent, right? And I joined there in early 2013. So that's 11 years ago. And my first project, right? My first project there. And you may not know, it's relevant to this conversation, but Kafka started at LinkedIn. And I think for all intents and purposes, all stream processing today is downstream of Kafka.
Sure. Yeah.
Okay. So there I joined what we called back then a graph database team. And basically this is, maybe they still have it at LinkedIn, but something where it stores all connections. So, all your first degrees and all your second degrees. And that's used for search relevance. That's used to show what's on your feed. That's used for everything. So it's a very core piece of infrastructure. And it has to be fresh. So I think this is the core, right? LinkedIn needs if you connect with someone and you typically search for that person very soon after, you want to see that search result right there. It cannot be late, right? But that has to go through a whole indexing process. It has to do everything to actually show it correctly, correct? So this is a very sophisticated piece of processing that has to happen fast, right? So my first job at LinkedIn was Samsa was also starting in 2013. To write an ingestion into the graph database using Samsa to speed up the time that your connection is indexed in your first degree, second degree, so that the rest of the site can be fresh, right? So I think for me, that's kind of I think stream processing, that's what I meant as a counterpoint to what Yingchen said. The demand for quality in products is increasing, right? Like people have tolerance to wait is less and less and less, right? You don't want your bank balance updated tomorrow. You want it now, for example. Whereas 20 years ago, no one even checked their bank balance every day. For example, expectations have shifted, right, from the world. And I think that's really where Kafka has gotten popular. And then the layer on top of Kafka, which we can broadly call stream processing, has gotten popular. And I think really it's to support these applications, right? Whether any application, if you have a sophisticated thing you have to do and you need to do it fast, you typically are going to do it on top of Kafka nowadays, or you should be thinking of doing it on top of Kafka nowadays, because the alternative is what you're going to have a bunch of databases and tightly coupled microservices with a higher degree of fragility. Those systems don't scale for these use cases. Kafka does scale. This is the layer on top of Kafka does scale. And that's what stream processing is for me. And, there are very different takes on it, which I guess, Kaivalya, you're going to get into. But I think that's how it started. I think it's just a need for better products across the whole
Yeah.
all products, I would say, right? And and I think it's going to keep going. Kafka is growing significantly year over year. Adoption is growing. Like software is still eating the world, and I think real-time software will eat the world, will eat the software world for a lot of things, and that's where stream processing, I think, has a bright future.
Interesting. Yeah, those are slightly different perspectives, and both are interesting. And you guys have coined some words, or let's say terms, and I want to dive deeper into those terms, right? Like for example, Yingjun, you mentioned about cloud native, right? And these are the applications that are built these days, and people want to be cloud native. Is this just a marketing term, or there is technical implications behind that? So I understand that when people, like, when different people talk about being cloud native, they mean different things, right? For example, in the cloud environment, you can really scale up and down really frequently. Is that what you mean? Or is it mostly about, let's say, storage layer, which is, let's say, using object storage, so you can save some cost there? So I would love for you to explain, or rather elaborate on the term that you use for cloud native use cases, right?
Yeah, definitely. So these days, I try not to mention cloud native because I think, yeah, as you just mentioned, it actually means a lot of things to people. Probably it means that we can deploy using Kubernetes, or probably it means that okay, everything is deploying AWS, right? Basically AWS native or GCP native, or it could mean object store based, right? So when I talk about for the cloud native, I actually means for mainly focus on the object stores, basically S3 based. So the thing here I can see is that for in the big data world, let's say 10 years ago, people have big companies like LinkedIn, Google, Facebook. They have big data centers, right? And they have probably tens of 100 machines, or probably thousands of machines, or even 10,000 machines, right? In Google's MapReduce paper, if you check, they published in 2004. I still remember that they actually have I think they claim that they used 10,000 plus machines, each machine with two CPUs, two cores, which is for pretty tiny machines, right? These days, who use that? Nobody use that. But these days, what do we have is that for essentially a different setting. Our single machine is more powerful, definitely more powerful. You can easily rent the 64 core CPU machines from AWS, right? So it's super easy. And definitely the CPU frequency is much higher, right? Compared to 20 years ago. And memory is way bigger than what we have 20 years ago. 20 years ago, probably 4 gigabytes, but now it's probably 400 gigabytes or even 1 terabyte, right? But most importantly, we have the object store, which means that we do not need to worry too much about data loss. Because we can just, as long as we can put our data in S3, we assume that the data will be persisted. But if you check 20 years ago, when we had MapReduce, they actually need to think about whether we will need to have, let's say, so-called HDFS, right? Or in Google, it was called, I forgot the name. Yeah, the distributed file system. So basically, they actually need to build their own, right? So they need to care about the data replication, a lot of stuff. But in AWS, in GCP, or in Azure, in the cloud, we do not need to deal with the persistency, all this kind of on our own. From the data system providers perspective, we do not need to deal with that. What we need to do is that how we can leverage the capabilities brought by the cloud. And what capabilities? Well, that's S3. And what else? For the compute, we can instantly boot a machine from AWS, right? We can definitely leverage that, and we can also boot for a much more powerful machine, much more powerful machines from AWS, right? That's what we can leverage. And with that, I believe that will definitely the systems we build today for the cloud, it will be totally different from what we had 20 years ago or 10 years ago, right? Where the people were still struggling with how to replicate my data in my own data center. They also need to think a lot about the fault tolerance, right? If I have 10,000 machines, the chance that a single machine failed is pretty high. But in the cloud, I do not need to worry too much about that because I don't need to first, well, the single machine is more powerful. I don't need to have so many machines. So the chance of a single node failed can definitely happen, but the chance will be much slimmer, right? And more importantly, even if a node failed, AWS can help me to deal with that because I can definitely always easily boot a machine right from AWS. I can maintain a warm pool if you believe that for the boosting a machine is too take too much time, but I can always make a warm pool, right? Maintain a warm pool to do that. So a lot of things changed, and that's why. So back to your question, when I talk about for the cloud native, I talk about for the object based, the object store based, S3 based architecture, and I'm talking about for the more powerful machines, and talk about okay, we probably don't need to deal with the persistency, and we can focus on, let's say, how to optimize the single node performance and how to deal with what the scalability of the compute, right? That's what I mean.
That makes sense. And if I understand correctly, so it basically boils down to the expectations the users have, and those have changed drastically over the last decade. Like as Apurva was mentioning about checking my bank balance, it has to be real time, but it also has to be available, right? So the fault tolerance expectation has also gone high in terms of the applications that people build these days, because they want to serve their customers globally and with high availability and high reliability. So probably cloud brings that power to the systems that we build these days, right?
Uh, Absolutely, because for any system, they need to think about what the fault tolerance. They need to think about the high availability, right? So these days, well, because we have S3, we do not need to think about how we can replicate data. But 10 years ago or even 20 years ago, we actually need to think a lot about how we can replicate data, right? Well, if you check the systems, all these kind of system papers published probably 10 years ago, they talk about the Paxos, they talk about the Raft. But nowadays, who talk about that? Nobody talks about that because we can always leverage S3 because S3 can replicate data for us. And it replicates multiple copies and can also replicate across data zones,
Yeah.
right? Availability zones. They can do that. And we do not need to worry about that. We also do not need to worry about the network latency. No, sorry, the network cost, right? That's how the systems like WarpStream, right, will get so popular because they can help people to avoid the network cost, right? Yeah.
That makes sense. Since we were talking about object storage, and Apurva, you mentioned about Kafka and the popularity of Kafka, and I was talking to Kishore, the CEO of Startree, and he also worked at LinkedIn. Probably, I don't know if you work together, but he mentioned that cost to emit a single event drastically went down, and that made Kafka a really popular choice because that enabled event processing, and then on top of it, people started doing stream processing. So the cost to emit a single event was drastically reduced and it was no longer costly. And yes, Kafka has played like the key role in making all these things popular. But mixing the world of object storage and Kafka, these days there's a lot of replacement systems that are coming up, right? Like for example, Warp Stream is there's Red Panda, there is also AutoMQ and systems like that are moving all the state away from Kafka brokers to, let's say, object storage. And that's been like a common pattern even happening for databases. So with this, Kafka is more like a protocol now, right? Like people support that. And would love to hear about your perspective, like where this industry or this trend is going when we talk about Kafka. Is it more like a Kafka, like traditional Kafka, or is more like Kafka protocol?
So you're talking about like what I said, all like Kafka is a de facto base layer for stream processing. And you're
Yeah.
asking, am I talking about the protocol or the implementations? Is that kind of the question? Yeah,
Yes.
100% the protocol. I agree with you. I think Kafka is, the de facto event streaming protocol. All stream processors, all real-time analytic systems, everyone has to learn to work with it, right? And as WashStream has shown, and Red Panda has shown, and Confluent themselves have Cora, all different implementations of Kafka keeping protocol compatibility. So when I say Kafka is a de facto, it is the protocol, right? Even Pulsar has a Kafka protocol implementation, for example, right? So yeah, so I think that's kind of like what's traditionally known as the network effect, right? Like it is the medium of exchange, and you have producers and consumers in a general sense understanding that protocol, and now it's, I think, entrenched. What's the stat? 150,000 companies use Kafka. That's what they, that's what Confluent puts out in the public statements. That's a lot of companies, right? And I think that's just going to snowball, and I think the protocol is going to be there for as far as we can see.
Yeah.
Because it is kind of complete, right? It does produce, consume, it does rebalancing, it does transactions, and you can keep adding to it. It's extensible, so it's going to be hard to
Yeah.
displace.
Yeah, that makes sense. And like talking about these protocols, I see like common trends happening. Like for example, with Postgres as well. Like people, like for example, Rising Wave is Postgres compatible, right? There's Yugabyte and there are other systems. They want to be Postgres compatible. So Postgres as a system is evolved and become more like a protocol or like the API layer that people want to be compliant with. Similar with Kafka and even
Hmm.
AWS S3, right? S3 has become this protocol. Like anything that follows that, and the implementation may be different. So we can draw parallels on that. But you also mentioned about the freshness of data, right? And I also want to clarify or want you to elaborate on that. So freshness could mean different things for different people, right? And for different applications as well. And I also want to relate it with real time, right? Because that also is a, let's say, an overloaded term, or real time may mean different things for different people and different applications. So how do you approach talking about freshness in terms of stream processing, or let's call it real time or near real time? What are these terms and how do you see it?
Yeah, I don't think these are technical terms, right? I think, I think it's a bit of a misnomer to kind of get caught up in like how to define it, right? I
Yeah.
think the important thing, and I think in general, this is, I would say, a critique I have of our industry is where we get attached to these solutions, these technical terms, and say they're important, but they're not really important, right?
Mm,
I think what's actually important is the use cases, right?
mm,
Right. For example, like it's a very standard practice, right? Google has an internal stream processor. All advertising is internal stream processors effectively that do what? Because you are an advertiser on Google, on virtually anywhere, you for the day, right? To spend on ads. It could be per click, it could be per impression, per 1,000 impressions, whatever, right? But you have, say, 200, $500,000 a day. You've set that with the advertiser, and you say you place ads and don't make me spend more than $1,000 per day, per 24-hour window, right? Now, that for me, freshness is important, because if they have served your ads for $1,200, that means the advertiser has lost monetizable inventory and they're losing revenue, right?
mhm. Yeah.
The closer you can get to the $1,000 boundary, the better it is for the advertiser, because typically the advertiser bears the cost. Obviously, the advertising platform bears the cost, right? If the advertiser bore the cost, it's even worse, right? Because now I've spent $200 more than I wanted. I should sue the person, right? Not for no fault of my own. So I think that's an example of a use case where I know Kafka Streams is used in many companies for ad
Mm,
pacing like this. Flink
mm,
is not yet. I'm not in that world as much, but I presume it could be used, right? I know Google has its own stream processor that does exactly this, right? It's in-house. But that's an example where freshness is important and stream processing is the only way to achieve it, because it's at scale, it's sophisticated,
mm,
and it has to be as close to zero lag as possible, as
mm,
much as possible, because there's a business impact. That's one example. You can say in fraud detection, right? Like when Walmart checks out, when you click checkout, you're checked for fraud. Is this someone who's stolen a credit card to buy something? And should I block this transaction? That has to be as low latency as possible,
mm.
right? For the user to be happy. You don't want to sit there 30 minutes for a checkout.
Yeah.
And it has to be correct, right? And it's complicated, right? So that's an example. Kafka Streams, Walmart uses it for their Walmart.com checkout, for example. So this is what I mean by freshness. And you can say in usage-based billing, spend limits, but you can say in logistics, in every vertical, right? You can have these cases where you need to be quick, and you need to be smart, and you need to be correct. And that's where, you need something like stream processing. It
Mm,
is the clear superior solution to anything else out there. So that's what I'd say. Forget about, like real time, not guess, like, what do you want to get done, right? What is the user experience you want to deliver? And then work backward to a solution. And in many of these cases, in many of these verticals, it is stream processing, whether it's, but the technology is kind of irrelevant.
I agree. These are mostly like this has been a cause of misunderstandings as well. When I talk to folks about, oh, we need real time, but they don't know what real time means for their specific application or use case. And you need to know that just saying we need real time or we need low latency doesn't say anything about the system, right? It has to be in terms of numbers. What do we mean for what use case? And you mentioned if you need like quick processing and low latency, stream processing is the way to go. So I would also want to elaborate that. What does it mean? Like why stream processing inherently is fast, and what makes it fast? Like in terms of understanding the differences between batch and stream processing, and how it is evolving.
Yeah, I would say, like, I think it's also a misnomer, frankly speaking. Maybe we can talk about all these things. I don't think the competition is between batch and, in my definition, right, all the examples I gave, right, I don't know if ever in the world a batch processor was used to do ad pacing.
Yeah.
Was Hadoop ever used for that? It wasn't. Hadoop was used to generate Google's index, or MapReduce
Yeah.
was used to generate the index, not to do ad pacing, right? So I think like it's not even a comparison point for me, for those use cases. Was
Yeah.
a batch system used to index the connection, a new connection in LinkedIn search? It wasn't. That I know for a fact. I was there, right? So it's not even a comparison for these use cases. These are core application use cases that have to be online to deliver an experience to some end customer, end user. Batch processing is data processing. It was never used for this, right? So I think that's the first thing. So that I won't even say it's a comparison to what I said. Maybe Yingjun has a different perspective. And yes, there are comparisons between batch processing and maybe real-time analytics and that world, but not in this application world. That's number one. And I think you mentioned batch processing, but I forgot the context. You said there's the comparison between stream processing and batch, right? And I'd say the comparison is more between stream processing and the traditional request response applications, where like a way to index, like a connection would be to write to a database and block all requests until that is indexed so that everyone has fresh data. That would be an alternate way to achieve the same thing, which is a synchronous request response architecture, which just doesn't scale, right?
Yeah.
Because, and that's where Kafka, I think, is the liberator, right? It's not, I think, and I have a different perspective. It's not the cost per event came down. It's more what it allowed you to do. It's basically an infinite buffer of events. It builds back pressure. It decouples these different applications in a very robust way. One topic can be consumed by thousands of people with one producer, so the fan out is very high. This allows your architecture to scale in a completely different vector, right? It's not so much the cost per event, but the flexibility that that model allows is what is the base layer for allowing these kinds of real-time apps to be on top of it, right? So that's what I say is a comparison point. It's between like request response, synchronous things versus decoupled event-driven things, right? And I think, frankly speaking, I think it's my prediction, I would say, is that stream processing model, event-driven model, is just going to be the dominant one, right? It's going to replace all the other things that try and work on top of the synchronous systems for these use cases. There's always a case for like, CRUD applications being synchronous, but there's a whole world of other things that benefit from being event-driven and asynchronous.
Interesting. I would add more to that, but I would love to hear what Yingjun thinks about this sort of comparison, and if there are use cases where this comparison kind of makes sense.
So good, definitely good question. I would say that batch processing is more general purpose, while stream processing is more focused on. They are more powerful in certain use cases. I can give you one single example. Let's say that I open a local restaurant, and I want to calculate, how much revenues got today, right? How many customers I got today. I don't need to have any stream processing system. No, I don't need to have that. I don't need to have a Reading Wave. I don't need to have a Kafka. I don't need to have this kind of thing. What I need to have is just I also don't need to have a Hadoop. I only need to have Excel. That's it. Do you think that's where Excel is for batch processing? Okay, for sure. Yeah, it's batch processing. And I don't really believe that's where anyone will claim Excel is for stream processing. It's basically, I get a batch of data and then I'll process it. That's batch processing. So I would like to say that for batch processing in this kind of like definition is more general purpose. Excel is also for batch processing, right? But in my Postgres, where it's more all SQLite, it's for those systems are for batch processing. But if you talk about the certain domains, or certain verticals, certain industries, certain use cases, where they are not okay with batch processing, think about LinkedIn, right? Well, I probably do not. I never worked for LinkedIn, but I probably don't need to emphasize how important it is for LinkedIn to keep the data fresh, right? When I connect to to you in LinkedIn, both of us want to see we are connected for sure. And for fraud detection, right? For sure, they don't really even want to wait for until the second day and say, okay, my money got stolen, right? They do not really want to have such kind of experience. And think about capital markets, think about the fintech companies. If they want to do, let's say, the trades, if they want to do stock trading, if they want to do, let's say, all kinds of compliance, they also want to do all kinds of strategy monitoring, they have to have the data super fresh, right? They have to get an answer in seconds, not even in minutes. They actually want to get an answer in seconds. So for stream processing, these are perfect scenarios, and these are all event-driven processing. I would like to call it event-driven processing because every time a new event comes in, let's say that we're in stock market, I place the order or I did a trade. I do want to see, okay, whether my trade gets processed correctly, and I do probably want to see, okay, my portfolios, right? I want to see the value of my portfolios, right? I do want to see those kind of results in seconds. It's also different from stream processing. Yeah, you also talk about the real time. I would like to say that real time is definitely a buzzword, and I try not to use that kind of word because when I talk to people, to many people, real time just mean, okay, my database should be faster. They think that, okay, I run a query in Postgres and it's too slow. I don't really want to have that kind of experience. I want to have a faster database. And then they say that, okay, look, I don't want to have a Postgres. I want to get a real-time database. I don't know what it means. They probably just mean, okay, a column store, right? Where they don't really care about the freshness of data. They just want to say that if I run a query on Postgres, I want to get a result faster in seconds, not in seconds, but probably in 100 milliseconds, right? Not to wait for, let's say, 10 seconds or 20 seconds. They don't really want to have such kind of experience. And that's why they claim that it's called real time, because for the results returns in real time once I issue the queries, right? But again, for stream processing compared to batch processing, I think stream processing is a specific use cases. But fraud detection, capital markets, logistic tracking, right? All these kind of uses, you have to use stream processing. But I do agree that there are some certain kind of use case where both stream processing and batch processing can work. For example, the ETL. ETL basically transform let's say that I want to ship my data from my Postgres to Snowflake, right? Do I really need to have that when my data moved in seconds? Probably not. I'm probably really happy if the data is synced to my Postgres Snowflake from my Postgres in 1 hour. That's fine. So for these kind of use cases, people were not judged by the freshness. They were judged, by which tool is more user friendly, which tool is I'm more familiar with. So let's say that if I'm a Spark user, I'm probably fine with just doing such kind of ETL using Spark, right? That's probably for batch processing. But they do not really consider too much about the freshness. They just care about, which tool I'm more familiar with, so I'm more happy, I'm more confident with, right? Or they think that, probably which tool is cheaper, right? For batch processing, yeah, in many cases it's cheap enough, right? Because, right, just one shot. But in some cases, let's say if I want to do some aggregations before syncing data into Snowflake, then probably I do want to have some certain kind of incremental computation. If I want to do incremental computation, then probably I have to use a stream processing engine. But that's not for, they do not really need the real time part or the freshening part. They only need the incremental part, right? Where the incremental is a king that dominates this use case. Then that's why they pick the stream processing system. It's not for freshness, it's for incremental. So back to your question, for stream processing and batch processing, I have to say that well, definitely these are two different things. When batch processing, okay, Excel is for batch processing. Everyone uses Excel. Everyone uses batch processing for sure. But if you talk about certain use cases, you have to use stream processing. There's no way you can use batch processing. Systems like Snowflake, that like Databricks, they will not solve their problem. You have to use a stream processor. And there are some use cases sitting in the middle, right? You can use either stream processing or batch processing. I think it totally depends on the user experience, and it totally depends on whether you really want to have incremental computation or full computation is good enough.
Yeah. I think that makes sense. And just to add from where this question is coming from, right? In my experience, I was working on, let's say, a system for usage and billing calculation, right? And I don't want to take names, but you can guess. And so there was this existing system, let's call it a legacy way of doing things, and that would run like Spark jobs and run daily and weekly and monthly and do different kinds of processing. Of course, there were problems because the data size was growing and the Spark job was fail and leave some state behind that, all sorts of debugging problems and observability problems. We don't really know what exactly failed, when it failed, and what is the current state, right? And then it would still work. Most of the times it would work, and it would create like a reports, and on based on that we'll understand what is the usage and billing and whatnot. And then there was this proposal where they said, you know what, we should move to stream processing. So the idea here was not, of course it would be faster, it would give you quick usage reports and quick billing understanding, but the idea was main to simplify the architecture as well. And that's when there was a lot of discussion around, okay, should we do batch processing, should we have stream processing? And then of course there were some added benefits when we thought about, okay, can we do stream processing, that kind of opened up some new opportunities for us. So since we are doing this on usage or real time usage and billing, we could also have real time monitoring in place, where if some usage is spiking, we can cut the data limit and whatnot. So I think it opens up new opportunities for business to even think about these systems, because sometimes business do not have the technical understanding. When the team goes to them and says, you know what, we want to re-architecture and change it to stream processing with these benefits, to justify this, they need some understanding like what exactly it is going to bring to the business, right? And cost is one, real time or fast or quick results is another. But I think the third one is it opens up new opportunities for you to think, to solve new business use cases, right? So that's where it was coming from.
I think, by the way, that's also what I meant by freshness, right? Like, I don't know what the system you're talking about, but in billing systems, you may want, it depends on the product, but all the features you can add if you have if you can react fast.
Yeah.
It's very similar to advertising. You can do spend limits, you can spend alerts, you can do all this stuff, which you just cannot do in batch. And if you do that, it can significantly improve your product. Obviously, I don't know what product you're talking about, but I think that's exactly what I was saying. It's not cost, it's not simplicity. Those are like solution oriented ways of thinking.
Yeah.
I like a technology, I like this thing, so I'm going to use it. Most businesses don't think like that. It's like, well, how do you help the business?
Right.
And I do think stream processing and this architecture exactly will allow you to do things you could not have done before. And that's why it's exciting.
Interesting.
So,
okay. So let's move away from discussions around names and terms and definitions. I think we all agree what we are talking about. And let's get deeper into understanding these different paradigms, right? So let's take an example here. Let's say I'm a company. Let's take again a use case for like usage calculations, for example, right? Like I want to calculate data usage of different SIM cards for these Lime scooters that are running across a city. And this is the use case. We can build on top of it. And I want to understand the mental model or build a mental model or to figure out what should I be using, and how should I go about thinking for a solution? For example, there are different paradigms. For example, there's Kafka Streams. People can have a separate cluster of Flink, or something like Rising Wave, where we can have a database and then just run queries and it will give you faster results. How should one who doesn't have experience think about these problems and figure out the best possible solution?
Yeah, I think it really depends on, I think what you said, Lime scooter usage data is a bit underspecified. So maybe we can add details that will help, you know, help answer exactly the question, Kafka Streams versus something like Flink versus something like Rising Wave.
Yeah.
So I have at Confluent, I was running the Kafka Streams, responsible for Kafka Streams and KSQL, which is SQL closer to Rising Wave, right? SQL stream. It was, I think we coined the term streaming database, right? That was something Confluent did when I was there. So yeah, the way I see it is that it really comes down to persona and what it is the business is trying to do, right? So now if right, your product is this online system that can limit usage of a scooter, right? If it is part of your online operations, if it is part of the feature set of your product, right? If it is a core differentiator of your product, especially, right? Typically, in these companies, which are digital first software companies, their application teams are building the system to deliver those features, right? Usage
Yeah.
limits or things of that nature.
Yeah.
Right. And if you're an application team building these core applications, right, and then going back to what we talked about, it needs to be fresh, it's sophisticated processing at scale, potentially at scale, that's what you're planning for. And your application developers are building these event-driven systems, right? If those things are true, then I think something like Kafka Streams is very attractive because you are still running an application. It looks like other applications in your environment. You have your same toolings, deployment models, observability systems. It integrates into your flow as an application developer, which is very different than submitting a job to a cluster and adapting to that. So I think that's kind of where Kafka Streams has really, really become popular. Right? Time and again, what I've seen is that people just pick it because they're building these applications. They like the idea. It's literally the framework has come to them in the context of the application versus them going to the framework. It opens up very clean operational models. Like who carries the pager? Well, the application team carries the pager. It's very clear, right? It's not, is it the Flink platform team versus the application team if something goes wrong? That's a complicated question in the alternate cluster oriented model, right?
Yeah.
And that's what I've seen in the business too. I mean, out in the world too. When these core applications typically prefer Kafka Streams, for this one reason. And then coming to SQL, I would say I think it could work, right? KSQL often was used in adjacent to Kafka Streams. I think the simpler jobs, at least for case, that's how what I saw, and I'm sure Yingjun would have a different view. But typically, complicated reactive application logic doesn't work purely in SQL. You need your Java code, you need imperative code to do that, right? But if you want to prep data, clean data, do that kind of stuff, SQL is a better interface, which is where something like KSQL often was upstream of Kafka Streams, right? But that's a different use case as part of the same stack, But I think so. That's kind of how I saw it break down. But I don't know. I'll pause there. But I think it really comes back to summarize, right? It is like who's writing the app for what purpose. If it's a core application that's part of your actual product, that's part of your business, application developers are writing it. Having an embedded model like Kafka Streams is very attractive for operational developer productivity and a variety of reasons.
Yeah. What is your take on that, Yingjun?
I think it totally depends on the user persona and their background. Let's say that so Rising Wave is Postgres compatible, so you can imagine that essentially many of our users and customers came from the Postgres world. And why they do that? They probably think that, okay, look, my Postgres is too slow. I want to have real-time processing, right? That's one use case. Some people want to build a dashboard using Postgres, and they fed for got stuck. and then they want to find some other databases, and they don't really want to change their queries, and they don't really want to move to, let's say, streaming. If I want to build a dashboard and then I want to make it faster, it doesn't really make a lot of sense to ask me to re-architecture my entire system, right? Well, it doesn't really make any sense. So they find that, okay, probably RisingWave can help, and because they can do materialized views, they don't need to understand what the stream processing is. They only need to care about, okay, it is incremental from their view. It is incremental view maintenance, and it can retain the fresh results. What they really care about. They don't really want to talk about the stream processing. They have never used Kafka. They just have Postgres experience. So but what we provide is essentially stream processing, right? RisingWave provides stream processing, but we don't really want to pitch them, okay, look, you want to have a stream processor. So our pitch is, okay, look, we can solve your problem with incremental view maintenance. And that's how but it's essentially incremental view maintenance is equivalent to stream processing, right? So both of them are incremental computation, and both of them can process return fresh results. They are same. That's one case. And for the Kafka users, I have to say that what I can see, most of the Kafka users will first check probably Kafka Streams. If they want to process data, right? There are definitely some use cases they probably do not really want to process data. They do not even have the demand to process data. They just send the data from one data system to another data system. Then they can just use Kafka. That's messaging queue. But if they want to process that data, they typically will choose from Kafka Streams because it's Kafka native, right? Because it's built for Kafka, right? And it's Kafka native, and it's and Kafka was written in Java. I know that probably there are some different versions. Repanda, I have some other versions written in different languages. But for Kafka was in Java, and they want to have a Java system or Java experience where they want to process data. Write their Java application. It's pretty native for them to, straightforward for them to adopt the Kafka Streams. For the KSQLDB or RisingWave case, or the even Flink SQL case, what I can see here is that it totally depends on user experience. If people are not familiar with Java, and they probably come from some other words that will probably, I don't know, Python word or some other word, they probably think that I don't really want to learn Java, probably don't really want to learn a new library, right? For anyways library. And I probably just want to use the queries I'm familiar with, or the languages I'm familiar with, then they probably will consider SQL because, that's everyone knows SQL, right? The data engineers, where everyone knows SQL. And that's why they choose SQL. And okay, so actually another reason they probably will pick SQL instead of the other languages would be that they don't really want to make their application too complicated. Because if let's say that I want to write Java code, then essentially I have to maintain the Java code. I have to, let's say, care about the Java version, so so on and so forth. But for SQL, it's okay. I can easily transform the data to my query to some other teams. My team doesn't really want to own this kind of stuff. I probably can transform this to the data application team. They can write their own stuff, right? Probably some other teams, they can just use SQL. That's the other reason I feel I find that probably SQL would be useful for some of the use cases. But again, if you talk about the adoption of the stream processors, I would like to think that I believe that's why it totally depends on the user persona. If people came from the database world, they will not choose it's really hard to pitch them to architecture or bring your, let's say, Kafka into your organization. They will not do that, but they probably think about, okay, I just want to have a database. And incremental view maintenance could be the entry point for them to adopt a stream processing system. They do not need to know stream processing, right? But for the Kafka world, Kafka Streams, in many cases, will be the most straightforward solution for the Kafka customer users, existing users, right? It's native. But if people think that they probably don't really want to learn Kafka Streams and they want to keep their application simple or probably make their code cleaner, right? Just SQL code, right? And probably can share across multiple teams without learning new languages or learning new libraries. Then they probably consider SQL solutions like KSQLDB, or probably Rising Wave, or probably Flink SQL, right? Yeah.
That makes sense. So it boils down to, what problem I am trying to solve, and the user, like, who is going to use this and what is the requirements. But let me add some requirements just to have some concrete examples of what we are trying to do here. So let's say, first of all, I want to enforce some data limits. That, let's say, someone just steals my Lime scooter, takes the SIM card out and starts streaming on YouTube or something and watching our podcast or something, and they consume a lot of data. I'm sorry, I have to open the door.
Yeah, go ahead.
Okay, so got my packet. Sorry about that. Yeah, so I want to implement, let's say, data usage limits so people can have some control and not misuse the product. So I want to do some real time limiting. So it's basically real time calculations, and then also consumption of, okay, what is the data limit or what is the usage at this point, and then do some logic. The other is on, let's say, I want to create a dashboard where I can see all my Lime scooters or by city and see where my most usage is going on, and produce that information and prepare a dashboard. So these are different use cases, probably have different guarantees as well, but still the freshness is important for both use cases. So what I want to do is, let's say I end up using Kafka Streams. I do some real time calculations. I have the state within the Kafka streams, and then I want to also expose this state. So, how do I go about it, and how should one think about it? So, if I remember correctly, there was also a possibility to expose a REST API on top of the Kafka stream state. So, you could just query that based on what your requirements are, like simple key value lookups. But I could also put that data in an aggregated form in smaller buckets in a database, and then let that database handle the read part. So how should one think about that? What are the possible options in the current state of the Kafka streams and other systems? And yeah, how should I make that call?
Yeah, I think that's a great example. And I think what you ended with is the typical thing I've seen. So this usage limits, if you're actually trying to say cut off that SIM card usage because someone stole it and is streaming, trying to
Yeah.
download some massive thing on it, and you want to, as soon as possible, cut them off, disable it so that you are not carrying this bill. That's very common. Like that's basically the same problem as app pacing. That's the same
Mm.
problem as spend limits in a usage-based billing system. So typically in those kinds of things, your application teams are building these real-time apps to compute real-time usage and then take an action like cut it off,
Yeah.
cut a SIM card off. And the faster you can do that, the better it is for your business, right? So that's typically either a Kafka Streams based application, or like they've rolled their own thing to do it, right? That's what I've seen a lot of, where it's not a job running somewhere else, typically in most companies, right? So, but the beauty of, again, going back, right? Kafka is a data exchange format, right? So Kafka Streams writes all these results back. And also what I've seen very typically is that that's loaded into something like Druid. It could be loaded into Postgres, right? Systems of that nature to then drive Dash. It could be loaded into a data warehouse. And then your real-time dashboards to kind of, for product analytics, and those use cases can be served that way. But it's still one pipeline that, that does the real-time reaction to for the actual product, and that can also serve any kind of reporting use case downstream. And by the way, it could serve reporting use cases that are visible to a user, right? I don't know in this context, but if the user wants to see how much I've used my scooter, for example, right? That could also be go through Kafka and all this stuff, like and then serve an app that the user sees, right? So that's, I think, the beauty of picking an event-driven architecture for these use cases, and there's many layers on top that are appropriate for different, different goals. And warehouses to real-time databases to streaming databases to actual streaming real-time apps, all of them work together, right? There's nothing exclusive here on top of
Yeah,
Kafka.
that makes sense. Have you also seen like a hybrid way of working where, okay, I have, let's say, my Kafka Streams topology, and I also have a database and something like, let's say, streaming database, right? And for some use cases, let's say I reserve the use case of Kafka Streams for really more advanced use cases. But then, since the streaming database can provide me SQL access, I can provide a simpler interface for, let's say, product analytics or those kind of people who are not really technical, but they know SQL. So that problem is solved, but I reserve my engineering teams for using Kafka Stream so they can write Java. So have you seen this hybrid model used as well?
I think I think for streaming databases specifically, for that reason, perhaps I don't know. Right? I
Hmm.
think the reason people pick things like streaming databases or real-time databases, Druid, Pinot, potentially Rising Wave 2 is, again, I think what's downstream. If you're serving dashboards
Yeah.
and the people building those dashboards know SQL, then you want to give them SQL that is fresh, that gives them fresh data, right?
Yeah.
But I think it's driven not so much that, because you need to have that dashboarding capability
Hmm.
as part of what your company needs. That's very different from saying you'll also have a streaming database because someone may need SQL, right? But I have seen it where, definitely Kafka Streams plus Druid, Kafka Streams, plus KSQL DB in some cases, Kafka Streams plus plain Postgres is not uncommon.
Yeah. Cool. Okay, so let's move on to answering some of the questions that I asked on social media, and people asked me to ask you these questions. So these are interesting questions and really important. For example, Alex Miller asked this question. He says, "What consistency is required for streaming computations? And do user care if the stream system produces answers which queries on static copies of data never would have returned?" So, how does consistency comes into picture?
Yeah,
Is the
that's
question.
a classic one. I mean, ultimately people do care, right? I think that was, do care about the correctness of the computations. Like these systems are used for actual ad pacing, actual financial use cases, right? So I think that people do care. I think it's again comes down to a trade-off, right? Stream processing is fundamentally a different model than anything else, right? Because your stream is unbounded, and
Hmm.
any answer you give is always relative to some portion of time
Yeah.
within which events occur, right?
Right.
Just typically called a window, right? And different systems have different ways of handling windows. Like Flink has watermarks where once your window closes, it's done. It's a very hard
Yeah.
stop. Kafka Streams is more like opportunistic, where you keep emitting updates as events come in
Yeah.
that belong in the window. It could be late arriving data or some of things of that nature. It sends an update, and then downstream things are expected to know how to handle updates. In both cases, right, there's trade-offs. And ultimately consistency in stream processing comes down to the system has to allow you to pick because
Yeah.
you can't have it all, right? I want fresh data. And it's ultimately like if you could have all the data that ever existed that are ever going to be generated and then give an answer, you pick
Yeah.
that, but then you may never get the answer.
Yeah.
So then you have to choose a trade-off within that, and choose within that, and the systems just give you the opportunity to pick what the model is for you. It is actually the biggest problem, I would say,
Yeah.
with stream processing, that it's hard to get your head around, wall clock time versus stream time, how to think about later arriving data, how to build systems that can naturally incorporate
Yeah.
the fact that, maybe someone lost a bunch of events, forgot to transmit them to you, but suddenly they arrived one day later and now you have to deal with it. It's not easy,
Yeah.
right? Everyone in the stream has to deal with it, right? And I think that's a mindset shift.
Mm,
But the underlying system should just allow you to pick. And I
mm,
think there's a lot of education we need to do as a community on how to think about these things. There's a lot of simplification we can bring, like preset patterns that deal with it in the most common ways. None of this exists, right?
Yeah.
That's something responsive eventually will get into.
Hmm.
But I think there's a huge opportunity to simplify this and give like 80-20. 80% of the stuff is few patterns, and give those patterns upfront, I think would be a super valuable thing.
Agreed. Yeah. I think consistency is important, but your system should be able to give users the ability to tune that, right? Because ultimately you cannot have everything. You need to have some trade-offs. Okay, so let's move on to the next question, which is one of my favorite topics, exactly once processing. And Kian Lee asked, do people care about exactly one stream processing? If so, how do people typically implement it, especially when it involves external system calls?
Yeah. I think people care again at what I just said, right? Like lots of financial companies use stream processing systems like Kafka Streams for all sorts of billing use cases, trade settlements, fraud detection, So I think they care. Like I think being correct within a time window reliably, not overcounting, not undercounting, all that
Yeah.
really matters. Um, it is actually a very hard problem to do it across systems,
Mm.
right? So Kafka Streams, you can call out, look up data outside, Ultimately, the good thing about Kafka and Kafka Streams is Kafka is a transactional log. It does have a two-phase commit protocol that, they're adding things that you can override it or hook into it in some fashion. So it gives you the primitives to kind of interface with external systems in a transactional way. But there are a few things you can't control, right? If you look up something at a point in time, and you look it up again at a different point in time and the something else changes, you know, that's actually a hard problem to solve. If you want to write transactionally to a remote system,
Mm.
they need to provide a primitive to hook in so that you can compare and set atomically, for example, or they need to provide primitives to allow you to do that transactionally. None of that is fully built out, I
Mm.
would yet, right? I think, there are techniques like causal logging where, you can actually, when you do a lookup to a remote system, you can log what that answer was and
Mm.
persist it in the stream, in the log, so that when you replay, you get the same exact thing again. You can figure out for certain subset of systems, if they provide compare and set, you can write to them atomically. Those are all opportunities, I would say, and I think exactly once across systems is historically called what you call XA transactions,
Mm.
which never took off. It's just so complicated.
Yeah.
And forget about like other systems having different definitions of consistency to begin with, right? So I think a hard problem. I think,
Yeah.
it's possible that those will be solved. Maybe they don't need to be solved, right? Because there's ways. I think one of the mistakes people make, frankly speaking, is that if all you have is a hammer, everything looks like a nail, right? And the analogy here is to try and solve it in this one layer of the
Mm.
stack, right? You have Kafka and you have a stream processor now. It has to do everything. And that's just not true, right? I think there's ways, if you take a broader systems design point of view, to solve the right problem at the right layer where it becomes significantly simpler, right? And an example of that is a lot of people I've seen at the entry point of their Kafka system have a deduplicator that deduplicates events on some external key. That's all it does. So now everything in once, right? Which is a very different solution to the problem was,
Yeah.
so I think those out of the box solutions, those broader picture solutions can be very powerful.
That makes sense. How checkpointing works with cloud native state implementation, is time for taking such a checkpoint significantly smaller than in the classic RocksDB based implementation? And this is asked by Ivan.
Got it. Yeah, I think again, we don't have Ivan here, so we don't know, but I think he means Flink checkpointing and like that idea where they kind of take a checkpoint at a very defined point in time across all operators of state so that they can roll back to that point reliably in the future. So I'm assuming that's what he means by checkpointing. I don't know. And then, so the question is, does that become simpler with something like SlateDB or object store native storage? And I think the answer is yes. Ultimately, and we have plans around this, but what object storage, any object store based system allows you to do, it allows you fundamentally to make this checkpoint process a metadata operation versus a data operation, right? So in Flink today, and I may be wrong here, so if I'm wrong, like you can correct me offline, but I think what you need to, for a checkpoint to happen, you need to kind of take the data. It's a delta from the previous checkpoint, but you have to take the data that is that is the delta between the previous and current checkpoint and write it to object store to complete the checkpointing process. And that's just a time-consuming operation. With an object store native system, you can just version, it's just a version of the segments in the object store. So you're just marking this checkpoint or this checkpoint is at this version, and there's a way to version it in a correct way, like with logical clocks, and that's it. So, it's like a symlink versus moving a file. So I think that makes it much, 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 much faster, right? And that allows you to do the same operation more cheaply, more reliably, gives you more options, because you can conceivably pause the stream, make everything drain, take a checkpoint that takes a few milliseconds and then keep going, versus having to build a flush mechanism through all operators, which is significantly more complicated, but you only do that because you need to do this asynchronously, right? So that's, I think it does significantly open up doors by moving the problem to a metadata level rather than the data level.
Yeah, interesting. By any chance, checkpointing, is it relevant to some systems like Rising Wave? Do you do checkpointing internally? And how does Object Store help?
Yeah, I always pitch people that essentially in Rising Wave or the so-called for the object store native system or S3 native system, the checkpointing is essentially the state. So they you can consider them the same. So how do we do that? Well, look, in Flink or in probably some other like big data systems, well, systems building the big data world, what they did was that they are not cloud native, they are not S3 native, which means that periodically they have to put their states, dump their states into object store. And then after processing, let's say 10 minutes later, I dumped again, right? Dumping the states into the S3 could be very expensive. That's first one. But definitely people will argue that, look, we can do incremental. Yeah, for sure. Yeah, we can do that part. But think about that. Well, essentially still you have to periodically dump the data into S3. And if failure occurred, what do you do is that you actually need to go back to, 10 minutes ago and reload the checkpoint from from S3 and replay from there. That's what happened in the big data systems. But in cloud native system, like Rising Wave, the thing here is that essentially every time you update something, it's updated into S3. The update will be persisting to S3. So if system failed, you do not need to load the data from S3 to your local machine. You do not need to do that. You just recover from there, and that's it. Well, because again, all the states are maintained in the S3. But definitely, it doesn't really mean that we do not really maintain anything in local machine. The only thing we maintain is essentially a cache. So that's the thing. For S3 native system, your persistent state is maintained in S3, while for local machine, it maintains the caches, which can be disposable, right? Well, it can go anywhere, anytime. It can be disposable, and it's just a cache. It's for query acceleration. But in the big data world, the thing will be different. Will be that their system is essentially, their state is essentially persisted in local machine. Well, they periodically archive the state into their S3 so that in order to ensure that even if the local disk failed or a local machine failed, they can recover the system. So that's the difference. That's a difference. So that's why I believe that in the back to the question, for modern database system, for modern cloud native or the S3 native systems, failure recovery will be much more efficient.
Okay. That makes sense. And again, S3 comes to the rescue. I mean, changes a lot of trade-offs that you have to make, of course, but adds a lot of value there. Cool. I think in the interest of time, we probably should end here because it adds a lot of things. We discussed more on how stream processing evolved and how does it work. Try to give our viewers a mental model on how people should think about different paradigms and different solutions out there. We also try to answer some of the questions that are really popular, exactly ones, external calls and consistency and importance of real time and all of that. Thanks, both of you, for joining me and sharing your insights. And I loved recording this episode. So, yeah, looking forward to releasing it soon. And thanks again.
Yeah, thanks for having me, Kaivalya, and nice to see you again, Yingjun. This was fun.